And welcome everybody to our meteorology segment. I'm your host Dan, aka smAsho. We're starting out by looking at pressure here on windy.com, and those lines that you're looking at, those are ISO lines, areas of homogeneous pressure. And pressure gives us all kinds of insight into what's likely to happen with your weather. If you see an H over your location, chances are you've got clear skies. I would also note the shock front created by the Himalayas. So the Himalayas are absolutely affected when it comes into global weather, and global weather patterns are indeed influenced by the Himalayas, as well as all kinds of other factors. So I started studying climate in 1987 formally, and there's actually some stories today about the North Atlantic overturning oscillation currents. The Gulf Stream flows to the north like this. And it turns out that if this gets disrupted by too much water, too much fresh water coming out of Greenland, it disrupts the North Atlantic oscillation, and it's a positive feedback mechanism that causes the entire northern hemisphere to get cold. By the way, last year we saw the Thames freeze. If you weren't aware of that, the Thames froze last year, and that is one of the canaries in the coal mine, along with a faster earthly rotate. When the Earth spins faster, folks, it's an indication that the planet is cooling and that there is less water in the oceans, as when a figure skater is spinning around and she pulls in her arms, or he pulls in his arms, you notice that he speeds up. Well, so does the Earth. When the equatorial bulge shrinks because of less water volume in the oceans, either because the water's gotten colder, cold water takes up less space than hot water does, or if it's because of water being deposited at the poles in the form of snow and ice, is totally irrelevant. Either one is an indication of likely global cooling. Earth rotation having been the fastest it's been since the 1960s, I think it was, last year in 2020. So we'll be monitoring this and putting out more videos about it. Let's just do the meteorology segment today and not get too in-depth into any of that climate stuff. Again, I've been studying this formally since 1987. In my 8th grade earth sciences class, I remember coming home and saying, hey, did you realize that global warming causes global cooling? Because if Greenland melts, it causes the upset of the North Atlantic oscillation, which causes the entire northern hemisphere to glaciate and turn to snow and ice? Yeah. We'll advance this into tomorrow. Here's the pressure forecast from the European forecast for pressure tomorrow. So yeah, folks, cold is a positive feedback mechanism. If the planet gets cold enough, it increases the Earth's albedo, which reflects too much energy back into space, creating a snowball Earth scenario and destroying entire civilizations. Global warming, not so much. A warmer planet means more food and easier times for most people. Cold kills people. Warm feeds people. That's the difference. Anyway, there's where we expect pressure to be according to the Euro forecast for tomorrow. Now, this video was streamed live to Twitch originally, twitch.tv/smAsho. And if you're viewing our content on Twitch, please tell your friends and foes over there on Twitch. We intend to greatly increase the amount of content we'll be making soon. If you're watching any place besides Twitch, check out the twitch.tv/smAsho. I'll bet you're able to view a website. Also, maybe check out the mobile app. It'll actually notify you when we go live like we are now. We've got some lightning over places like southern Minnesota, western Wisconsin, most of Iowa, and northern Missouri, moving into Illinois. Also a little bit of lightning in Idaho and Wyoming and off the Atlantic coast. Looks like a little bit moving into southern Texas as well there near San Antonio. Here's a real-time lightning map. I like to go to lightningmaps.org when I hear thunder. And I think we've got some terrestrial lightning here over northern Missouri. Maybe not. Anyway, we'll just zoom out to show you the... Oh, there we got some strikes. Some lightning in Lake Michigan. Please leave us a comment if you're viewing the videos from a laker. Or perhaps just a regular old boat on Lake Michigan. Some lightning north of the, is that the Black Sea? I think that's the Black Sea. Anyway, continuing on, here's your weather.gov map, and we don't have very many warnings here. A little bit of flood warnings, flood watches there. Flood watches there around the Florida Panhandle connection with the rest of the peninsula. Some heat advisories there, or those red flag warnings there in the central Rockies, and some fog around. I think we've got some fog here, actually. Next, I wanted to just take a brief look here at the 10 hectopascal winds. Now, this is an extremely computer-dependent model right here, as this requires a lot of data to be crunched in order to get the 10 hectopascal winds. This is actually low-pressure winds. And you can see the way we've got this clockwise rotation here around the northern hemisphere. So again, this is the 10 hectopascal winds. I just wanted to bring this up because this is sort of one of the components of global weather. And as the hemispheres transition from summer into winter, we see these systems changing. So here's the much more concentrated 10 hectopascal winds. And by the way, the wind speeds at that pressure, 238 miles per hour there. And you can see a bit of a kink starting to form here in the southern Indian Ocean at this pressure. Again, it's actually very low pressure winds, and it requires all kinds of computer algorithms in order to extrapolate this data. It's not just the wind, it's the wind at that pressure alone. So we normally just look at the jet stream, and there is the jet stream of the south geomagnetic pole. Here is the jet stream at the north geomagnetic pole. And we'll show you the normal views here. Here is the eastern portion of planet Earth in terms of jet stream, still blowing backwards over the western Pacific and eastern Indian Oceans. Pretty concentrated jet streams there in the southern hemisphere. Here are the surface winds of the eastern portion of the planet. And thanks to all of our viewers who are reflected in this view of planet Earth, cheers. Tell your friends and foes about the channel. We need to appeal to the market around this area. And thanks to our viewers in Australia and Tasmania and New Zealand and Thailand and Malaysia, etc. Here are the surface winds of the Western world. And we tilt this a little bit to the north because there are so many more people on this portion of the planet than the south. Here are the jet streams of the west. And you can see some cold air being injected all the way down to Louisiana here, as the jet stream blowing way down to the south and then making an abrupt, nearly 180-degree bend right near the Gulf Coast. And we've got quite cold temperatures in Pennsylvania here as we're getting some Great Lakes air moving into the mid-Atlantic states. Before we continue, let's give thanks to our patrons. The true source of funding for the content, patreon.com/smashamash if you want all kinds of background information, early alerts, and more. Patreon.com/smashamash. Thanks to our patrons. Please visit our own website. Check out our smAsho merch link. If you click that, by the way, smashamash.org will redirect you to this site, smashamash.com. If you click on smAsho merch, it'll send you here. Today's featured product is Mansa, Make America Not Suck Again. So making America not suck again is up to you. And let me just read my caption here. I just wanted to check the life of the stream. Make America not suck again. It's up to you, not the government. Who has been making America suck? Who? Who's been responsible for making it not suck? Who might that be? Was it the World Health Organization, a government, the CDC? Please. Make America not suck again. It's up to you. You can find the link at smashamash.com. Smashamash.org will redirect you. And there are 9 designs currently on the shop. There is a quick tidbit. To see more, you'll have to go visit yourself. We appreciate your clicks. Next, looking at the U.S. Doppler radar. And we see some rain here moving in a strange direction to the northeast in the northern Rockies, into Montana, and so on. Again, the jet stream coming down like this, and then back up like this, and then sort of a second jet stream coming like this, influencing the patterns. Next, the cloud layer. And there's what's currently going on in the cloud layer. Here's the water vapor map. And there's actually some dry mass of air right down in here. Looks like it's trying to move to the northeast there. Anyway, that should give you some insight into the flow of that moisture there moving into Montana. And here's your recap. U.S. Doppler radar map. Cloud layer. And there's water vapor. And thanks for tuning into the meteorology segment. I've been your host, Dan, a.k.a. smAsho, signing off from the Smash News Network, least busted, naming news.